In this video, we will see contiguous memory allocation technique and the problem associated with contiguous memory allocation. To store the data and to manage the processes, we need a large sized memory, and at the same time, we need to access the data as fast as possible. But if we increase the size of the memory, the access time will also increase, and as we know, the CPU always generates addresses for secondary memory, that is logical addresses. But we want to access the main memory, so we need address translation of logical address into physical address. The main memory interacts with both the user processes and the operating system. So we need to efficiently use the main memory. Main memory is divided into non-overlapping memory regions called partition. And the main memory can be broadly allocated in two ways: contiguous memory allocation and non-contiguous memory allocation. Here, contiguous means continuous. The memory management techniques are basic techniques that are used in managing the memory in operating system. Memory management techniques are basically classified into contiguous and non-contiguous. In this technique, in contiguous memory management technique, memory is allotted in a continuous way to the processor. It has two types. One is fixed partition scheme and then variable partition scheme. In the fixed partition scheme, memory is divided into fixed number of partitions. Fixed means number of partitions are fixed in the memory. In the fixed partition, in every partition, only one process will be accommodated. Degree of multiprogramming is restricted by the number of partitions in the main memory. Maximum size of the process is restricted by maximum size of the partition. Every partition is associated with the limit register, and the limit register has two limits. One is lower limit, which is the starting address of that partition, and upper limit, which is the ending address of that particular partition. In internal fragmentation is found in fixed partition scheme. So you can see in this example here, a process needs only 30 KB here. A process needs only 30 KB memory. So here these are all fixed partitions. So we allocate this entire 50 KB partition to that process. So here we allocate 50 KB to the process that needs 30 KB. So 20 KB that is internal to the process, but that is not used by the process. So what is internal fragmentation? Is a part of the memory which is available to the process but not used. That is known as internal fragmentation. In fixed partition, internal fragmentation is a problem. To overcome the problem of internal fragmentation, instead of fixed partition scheme, variable partition scheme is used. In the variable partition scheme, initially memory will be single contiguous free block. Whenever the request by the process arrives, accordingly partition will be made in the memory. If the smaller processes keep on coming, then the larger partitions will be made into the smaller partition. The problem here is external fragmentation. Now we always see this, for example, here take this fragmented memory before compaction. It's a technique for external fragmentation. See, this variable partition scheme applicable here, it divides the memory to the requested processes according to the required memory. So it leaves the scattered memory in the entire memory space, which leads the memory available is enough to accommodate further request, but it is not contiguous. This is the problem of external fragment. External fragmentation is found in variable partition scheme. To overcome the problem of external fragmentation, compaction technique is used, or non-contiguous memory management techniques are used. We will see non-contiguous memory management techniques in later video. And compaction here, it is a technique here moving all the processes toward the top or towards the bottom to make free available memory in a single continuous place is called as compaction. Here you can see memory is fragmented, scattered throughout the memory space. Now what we are going to do, we are going to move this entire scattered memory into a single big whole place. Compaction is undesirable to implement because it interrupts all the running processes in the memory. In the next video, we will see non-contiguous memory allocation techniques, which is paging. Until then, thank you.